Okay, notes on trigonometry with right triangles. Now, all trigonometry is are functions used to help solve in geometry. Tomorrow's lesson we will look at how you graph these functions, but today we're going to look at how you apply them. Now, there's a lot of calculator stuff with this. I'm going to try to walk you through it real quick. First of all, on the calculator in geometry. Now, in Algebra 2 and algebra classes, sometimes you change this, but in geometry, we are going to go to the mode button on the calculator. And when you turn it onto mode, you're going to go down to the one that says degree. And you're going to put that and highlight degree on your calculator. Now that's important because these are in degrees. Now again, in Algebra 2, sometimes that changes. But for us right now, we're going to do it in degrees. And all you do here is you use the Trig buttons. They're called sine, cosine, tangent. On your calculator, they look like sin, cos, and tan is what they look like. So in this case, all we do is once our calculator mode is in degree, we just go to cosine, cos. We type in the numeric value here, which is 22 on the calculator, and then press enter. And then it says to the nearest 10,000th. So let's think about it, tenths, hundredths, thousandths, 10,000. That'd be 4 decimal places. So in this case, it's 0.927. It's 1/8, so that rounds up to 2. So rounding, that would be our numeric value. So not bad there. You just got to type it in on the calculator. Now, there are things called trig ratios. Now, with trig ratios, there are different ways different teachers teach this. I teach what is known as SOHCAHTOA. SOHCAHTOA. And what that means is sine function is opposite over h is the hypotenuse. So yesterday's lesson we looked at legs and which one's the hypotenuse. I'm going to run out of room here. Okay, cosine. So cosine is called adjacent. Now all adjacent means is beside of. And we'll talk about that as we look at this particular example over hypotenuse. And then the last one is tangent. And tangent is, go back to our O earlier over here, that's opposite over A is adjacent. Okay, now, when we look at cosine, when it says write the trig ratio, it's always based on the angle itself. So in this case, our angle is Z. Now back up in the previous problem, they actually gave us a numeric value for the angle, 22 degrees. But in this case, they're using the variable Z. One thing to note, capital letters always represent angles. Lowercase letters represent sides. Let me say it again. Capital letters represent angles. Lowercase letters represent sides. The sides will always be across from the angle. In other words, side Z would be the 21 here. Why? Because it's across from angle Z. Also, side Y, in this case, would be the hypotenuse because it's across from angle Y. So hopefully that makes sense. So what I'm going to do now, I'm going to come back over here on this side, and I'm going to get rid of some of this stuff. Okay. And let's go back here and let's do cosine. So again, remember I said SOHCAHTOA. So I'm using this one. So cosine, so here again is my angle. Cosine is adjacent. So cosine of angle Z is equal to a ratio, a fraction, adjacent, my A. The side adjacent to Z. Now, adjacent just means next to. Now, there are actually two sides next to angle Z. There's this side and this side. Well, in this case, we're using the 20. Now, the reason we are is because y already has a name. It's called the hypotenuse again because it's across from the right angle. So the one adjacent is the one that's next to the angle that is not the hypotenuse. So adjacent, which is 20, over h, which is the hypotenuse, which we just got through saying is 29. Now, that is our ratio or fraction. Always try to reduce those if possible. Okay, next, we are trying to actually find the angle measure to the nearest degree, okay? So, again, we're back to the calculator. Always, again, make sure your mode is in degrees. Earlier, I'm going to scroll back up here a little bit. Earlier, what we did was we did cosine of 22, and we just typed that in on the calculator. Well, this time, we don't know what the angle is, but we know what the value should be equal to. It should be equal to this. So we're going to treat this like an equation, and I'm going to get rid of some of this stuff here so we can see it a little bit more clearly as we work through it. But we're still just going to use the calculator, okay? So all we do is we go on our calculator. Again, make sure our mode is in degrees. Our equation is cosine x equals 0.3746. Now I need to get rid of this cosine because I want to get x by itself. The way I do that is by using what's called inverse cosine. Now it's like any other equation. Whatever I do to one side, I've got to do to the other. So I have to do inverse cosine on this side as well. Sorry. So basically what happens is these two things cancel, leaving x equals. Now what I do, I type this on the calculator exactly as it is. So how do I do that? If you go back to your calculator button, you find cosine right above it in different color letters, you'll see inverse cosine, this right here. So all I do is press second cosine button, type in my decimal 0.3746, close my parentheses and press enter, and I end up with x is 68. Now it says to the nearest degree, so it's 68.0, so that is 68 degrees. So I'm doing the same thing over here. So I'm going to pause the video, I'm going to work this one, then you can check your answer. So in this case, it's 84 degrees. Now actually what you get is 83.98, so then it's the nearest degree, so you have to round that up to 84. Okay, so I'm going to get rid of all this stuff, and we're going to do these last two problems. Okay, so this next one is, it says find the measure of the indicated angle to the nearest degree. So now we're looking for the angle. So now this is how it's related to the previous problems. We're looking for this question mark here. I'm going to call it x, the angle. Now, this also goes back to up here, our trig ratio. We have to figure out a ratio. So in this case, from this angle, x, this is the opposite side. Why is it opposite? Because it's across from it. What side is this? This side right here is the hypotenuse because it's across from the right angle. So I have opposite hypotenuse. So I scroll back up here to the top. I see OH right here is with sine. So I'm using my sine ratio. So sine of my angle, which in this case is x, what I'm looking for, equals my ratio opposite over hypotenuse. Now basically all I'm doing is what I did in this previous problem. What I'm going to do is divide 34 by 44 and get a decimal. So I get sine x equals 0.7727, and that all repeats. And then just like above, I'm going to do inverse. And then I get, so if I do inverse sine of 0.7727, and you can go further if you want to, but 4 I think is enough. And I get 50.5. Again, it says to the nearest degree. So in this case, I'm going to get, and I should do approximately here, 51 degrees. Okay, let's do the next one real quick. That is the, again, opposite side. This one is the adjacent. Now, why is it not the hypotenuse? Because, again, it's not across from the right angle. It's next to the angle we're looking for, and it's not the hypotenuse. Okay, so, again, you can scroll up to the top. OA, 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 which is right here. Opposite adjacent. That's the tangent ratio. TOA. TOA. There you go. So tangent of the angle, which I'm going to call x again, is opposite over adjacent. So again, I divide 7 by 24, get a decimal. So I get tangent x is 0.2916 repeating. So then I do the inverse again. Oops. Inverse tangent. So I go on the calculator and I do second tangent button, 0.2916, and I get, again, approximately, that's 16.26, that'd be approximately 16 degrees. So that's application of the trig functions using it in terms of geometry.